Hey guys, so in our last video, we talked about the 5 types of reactions that we might see in chemistry. So we have our combination, our decomposition, single replacement, double replacement, and combustion. Today, we're going to look at what those types of equations and reactions have in common and how we can write them in order to clearly communicate what we want to say to the reader or to the audience of the equation. There are 3 kinds of equations that we can write. The first kind of equation we can write is called a word equation, and not surprisingly, those are written in words. The second type of equation we can write is a formula equation, and the formula equation includes the correct formulas for all of the chemicals in the equation. And lastly, we have the balanced chemical equation, and this includes the formulas, but it also includes the relative numbers of moles or molecules that react or are produced in the equation. And those are represented by coefficients. So in today's lesson, our goal is to learn to take a word equation and transform it first into a formula equation and finally into a balanced chemical equation. So starting out with a word equations are considered qualitative. Remember, qualitative does not include any numbers. So we might say something like hydrogen and oxygen form water, or nitrogen and hydrogen produce ammonia. When we do that, we're putting in words for the symbols that are written there. When we do this, we substitute the plus sign. We read that as either reacts with or and the arrow means yields or produces. So we might say hydrogen reacts with oxygen to produce water, or nitrogen and hydrogen yield ammonia. So those would be 2 ways that we could say these word equations. The next step is to take the word equations and to turn them into a formula. So for each of these, we're going to use our rules from chapter 9 and turn them into formulas. So when we look at something like hydrogen and oxygen yield water, we have to consider what is the symbol, the chemical symbol for hydrogen. And remember, hydrogen is part of that 6 in the shape of a 7 that come with the 2. So hydrogen is H2. And oxygen is also part of that group. So oxygen would be written as O2, and they're producing water, H2O, which we know is the formula for water. So we're going to use our naming rules in order to come up with the formulas for each of the components of the word equation. Another example is nitrogen and hydrogen yield ammonia. So nitrogen is also part of that group of 6 in the shape of a 7. So we would write N2. Good. And for hydrogen, we would write that as H2. And the formula for ammonia, you may not know it off the top of your head, and that's okay. I don't expect you to. The formula for ammonia is NH3. So we have taken the word equation, hydrogen plus nitrogen yields ammonia, and we have composed a formula equation, N2 plus H2 yields NH3. Some little rules that can help you here is that elemental gases, that's that 6 in the shape of the 7 I was telling you about, that group is going to come as a 2. Those elemental gases are over here, and they're coming in the shape of a 7. These are the 6 elements that we expect to see as a 2 with a 2 when we write them alone, and hydrogen over here. Our metals, most of the metals of the periodic table will come just alone: sodium, magnesium, calcium, no subscripts on them. And then there are some other rules for things like sulfur likes to come as a set of 8, and phosphorus likes to come as a set of 4, but I will not require you to know that. Just don't be alarmed or set off if you see S8 or P4 in a substitution reaction. We've come up with the formula equation. The last thing we need to do is balance it. And this is something that I know has been bothering some of you about the predictions that we were making before. We want to make sure that if we have 4 oxygens on our reactant side, that we also have 4 products on the product side. And so we want to make sure that we have equal numbers or equal amounts of atoms on each side of our reaction line. So when we start with our word equation, like hydrogen plus oxygen produces water, we get, already we know, a formula equation like H2 plus O2 yields H2O. But we can take this one step further and we can balance this equation. Balancing, everyone kind of has their own way of doing it. Some people feel like they can just see it, but that's not a very good way to teach it. So I use this, what I call a T chart, in order to balance the equation. So I draw a line under my equation and also through the yield sign so that I separate my reactants from my products. And now what I do is I write down all of the elements on each side of my chart. So I have hydrogen and oxygen, and I have hydrogen and oxygen. And you'll notice that I do not include any subscripts here unless it happens to be a polyatomic ion. Now what I do is I do my accounting. I am going to keep track of how many of each of these elements I have. So hydrogen is H2, leaving me with 2 hydrogens. Oxygen is O2, leaving me with 2 oxygens. Product side, I find 2 hydrogens, but only 1 oxygen. So I have my initial numbers, and typically you'll find that at least one of them is out of balance. In this case, my oxygens are out of balance. So what I'll do is I need to put a coefficient in order to balance out my number of oxygens. This is really important for balancing. You may only add coefficients. Only add coefficients. Coefficients are the big numbers that we put in front of the formulas. So in order to get 2 oxygens, I need to put a big 2 here. That 2 multiplies oxygen by 2 to give me 2 oxygen. But it has another effect. That 2 also distributes to my hydrogen. And when it does that, it changes hydrogen from being 2 to being 4. Now, in my personal shorthand, and this is just a Mrs. Wally thing, in my personal shorthand, whenever I make a move on purpose, I write times 2 equals 2, I write the whole thing out. And whenever something happens as like a side effect that I wasn't trying to do, I cross it out and put a 4. I personally like that because then if in case I get lost or I wish I could change something, I can kind of remember whether I did that move on purpose or whether that was a side effect or a consequence of something else I felt I needed to do. It helps me keep the concepts organized. You don't have to do it that way, but this is how I will write it. Again, I write out the times 2 equals 2 when I'm doing something purposefully. And when that something has a consequence or a side effect, I simply cross out the number and put the new number. So what I'm going to do now is put a 2 here because I would like to change this purposefully, right, to be 4. And now my equation is balanced. And at this moment, this up top is your answer. All of this is the work. So when I say answer the question and show your work, I do want to be able to follow along through the math. We're just going to work our way through a number more of these. So we start out by making our T chart. Nitrogen and hydrogen, nitrogen and hydrogen. 2 nitrogens on the left, 2 hydrogens on the left, 1 nitrogen on the right, and 3 hydrogens on the right. So these are both out of balance. And it really truly doesn't matter which one we solve first, but I typically see something like this and think, ooh, I'm going to have to find a lowest common multiple. You can either think after that, I don't want to do that, I'm going to put it off, or I'm going to get that out of the way and do it now. It really doesn't matter. I'm going to think, I want to put that off. I usually procrastinate the parts of the problem that I think are going to be difficult, and I find that that tends to work out in my favor. So I'm going to start with nitrogen. If I want to balance my nitrogens, that would put a 2 here. Times 2 gives me 2 nitrogens, and that has a consequence or a side effect of creating 2 times 3, 6 hydrogens. And now that I have 6 hydrogens, I move to the other side where I can say, okay, if I want this 2 to actually be 6, I need a 3 right here, times 3 to give me 6, and everything is balanced. Once again, this up here is my answer. And because of our distance learning, it makes good sense right now to realize that if I asked you what are the coefficients for this reaction, they would be 1, 3, 2. Make sure that makes sense to you really quickly. 1, 3, 2. We keep them in order, going left to right in the same order that the elements are. As a matter of fact, why don't we make sure that we answer that way for our question in this Edpuzzle? Let's try another one together. Before we get started balancing this one, what kind of a reaction is it? You guys are in a benefit here where you get to practice your types of reactions as we continue. This nitrogen one up here, that one is a synthesis or a combination reaction. And this one down here, hydrocarbon and oxygen make CO2 and water. This one is combustion. When we balance an equation like this, we're going to start with C, H, and O. 1 carbon, 4 hydrogens, 2 oxygens on the left. Now, the right-hand side is a little bit more tricky. 1 carbon, that's easy. 2 hydrogens, still easy. The tricky part here is our oxygens. We have 2 plus 1 oxygens, right? We have this like plus sign in between. So that means that I have 3 total oxygens here. All right. So remember when I said that we like to solve out our hydrogens first? This looks complicated, doesn't it? 2 plus 3, and there's 2 over here, but these ones are separated, and I don't really want to mess with that. So I am going to leave my oxygens. I'm going to ignore them. I'm going to ignore my problems and hope they go away. Not a good life lesson, but pretty decent in terms of balancing. So I'm going to leave them there. And I'm going to solve my hydrogen. So when I go to make hydrogens even, I need to put a 2 as my coefficient here. That times 2 gives me 4. And now here's the tricky question. How many oxygens do I have? 2 plus, this became 2. I have 4 oxygens. Not 6, like you might have thought, but 4 oxygens. Now that I know I have 4 oxygens on the right, it's very easy to come in and solve my oxygens on the left. I'm going to put a 2 here, and my ratios go 1, 2, 1, 2 across my answer. My answer is CH4 plus 2 O2s yield CO2 plus 2 waters. Let's try some more. What you'll notice about when I wrote this one down is I left space in front of each of my formulas so that I had room for my coefficients. That's a little trick or a hint that sometimes helps with the balancing, is just to make sure you've left enough space. So I'll make my T-chart and we'll fill everybody in. Once again, C, H, and O, C, H and O, 3 carbons, 8 hydrogens, 2 oxygens. And on the right-hand side, we are 1, 2, 3, again, 1 carbon, 2 hydrogens, and my 3 oxygens, remember 2 plus 1 over there to give me my grand total of 3. Once again, I don't want to mess with my oxygens first. I want to wait and see if they will solve themselves for me in some way. So what I'm going to do here, I have 8 hydrogens and 2 hydrogens. I am going to put a 4 here because 2 times 4 equals 8. So my hydrogens are all set, and we need to think about what that did to our oxygens. That made them 2 plus, remember we distribute 2 plus 4 for a total of 6 oxygens. And I would be ready to balance my oxygens, except I have this other problem, right? My carbons are not balanced. So what I'm going to do here is I'm going to put a 3 in front of my carbons. Times 3 gives me 3 carbons. 3 times 2 gives me 6 oxygens plus 4 oxygens gives me 10 oxygens all together on the right. And now I can come in and say, okay, I would like 5 oxygens on the left. So this oxygen accounting is one of the things that makes combustion reactions just a little extra difficult to balance. Okay, we have one more to do. BaCl2 plus Aln forms Ba3N2 plus AlCl3. What kind of a reaction is this? Of course, it's a double replacement reaction. Very nice. And we have 4 players or components, Ba, Cl, Al, and N. And you want to keep them in the same order on the other side, even though they come in a different order, because you want to be making your comparison down the line. Our eyes do a better job at following along with that. So we're going to keep them in the same order, Ba, Cl, Al, and N. I typically just do whatever order is on the reactant side and keep it the same on the product side so that I'm able to make straight line comparisons. You'll notice it does make a difference. So we go ahead and fill in our first numbers. So we get everything sort of set up to begin with. And then it's time to start balancing. We just got to jump in somewhere. So I'm going to start with Ba because this seems like a pretty simple one. I can see already that what I would need to do is put a 3 here, coefficient of 3 in front of BaCl. Awesome. That has a side effect. It turns chlorine into a 6. So I'm going to go fix chlorine. Chlorine is a 3 over here. So in order to make that a 6, I'm going to go to a lowest common multiple. I'm going to put a 2 here. Times 2 gives me a 6 for chlorine. And that distributes also has a side effect for aluminum. Aluminum becomes 2. Now I come over to the left. I want to fix aluminum. Put my coefficient of 2 here in front of aluminum. Times 2 gives me 2. Has a side effect. It also applies to nitrogen. Nitrogen becomes 2 and boom. Solved. So my ratio here would be 3, 2, 1, 2. My answer would be 3 barium chloride plus 2 aluminum nitride yields barium nitride plus 2 aluminum chlorides. So when we're working these problems, that looked like it was going to be a mess. It might have felt intimidating when you first started, but in the end, it works out balancing very nicely. And more times than not, that is how balancing is going to work out for you. So today I'd like to go over some tips and tricks to help you become excellent at balancing any equation. The first one is to concentrate on balancing elements one at a time. Just do the next right thing. Be like Anna, okay? I don't know if you guys have seen Frozen 2, but just do the next right thing. Just balance the next thing in front of you. Try not to get overwhelmed with, well, but I don't know what I'm going to do about the carbons, or I don't know what's going to happen with the oxygens. Just balance one at a time, and just keep moving through. You want to start by balancing atoms that are combined and only appear once on each side of the equation. These tend to be the easier ones to balance. So when we were doing that combustion reaction and we had oxygen split into CO2 and H2O, that means that it is not appearing once, it's appearing twice. That gives us the clue to just leave it till the end, just ignore that problem and hope that it starts to go away for us. This next tip, number 3, is really important. We need to treat polyatomic ions that appear on both sides of the equation as a single unit. And I'm going to go ahead and balance one like this with you right now. We're going to balance this one that you guys are looking at here. With a reaction like this, what we're saying is we want to treat our polyatomic ions as single entities. So when I'm deciding what I have here, I see that I have aluminum on both sides of the equation. I have sulfate, the polyatomic ion sulfate, SO4. I have that on both sides of my equation. I have calcium on both sides of the equation. And last but not least, I have hydroxide on both sides of the equation. So when I go to balance, I'm going to make 4 things. Al, SO4, see, I am keeping the subscript there because it is a polyatomic ion. Ca and OH. And on this side, I'm going to do the same group of 4. Al, SO4, Ca, and OH. So when I go to figure out how many I have, aluminum is pretty straightforward, that's 2. SO4 has a 3 on the outside of the parentheses. That means I have 3 SO4s. Calcium, just 1. Hydroxide, once again, hydroxide has a 2 on the outside. That means I have 2 hydroxides. On the other side, I have 1 aluminum, 1 SO4, 1 Ca, and 3 OHs. Now that I have this part done, the balancing just looks the same as any other problem that we've done. So I'm going to look at my aluminums, I'm going to see that they're out of order, and I'm going to put a 2 here. Times 2 gives me 2 for my aluminums, but that also changes my hydroxides to be 6. Then I'm going to look at my SO4s, and I can see that my SO4 is a 3 and a 1, so I need a 3 here, times 3 to give me 3, and that also affects my calcium. It becomes a 3. And so now I look back over here, and my calcium is a 1 and a 3, so I'm going to put a 3 here. That's going to times 3, give me 3 calciums, and distribute to make hydroxide 6. And there it is, all balanced up. My coefficients are 1 to 3 to 2 to 3, and my equation is all balanced. So the trick here is recognizing those polyatomic ions and keeping them together. You could solve this without doing that, but then you would have 4 oxygens here plus these oxygens here, and you'd have to be adding and multiplying, and it would be real messy and complicated. It can be done, it's just not that easy. And so the trick or the hint is to keep those polyatomic ions together so that you can treat them as a single entity. The trick is just that we want to treat our hydrogens and oxygens at the end. We want to keep them till the end because they tend to work themselves out. That just happens to be what happens as you balance the other elements that are in your chemical equation. You happen to balance out and write the oxygens and hydrogens, or at least get them much closer to being correct if you just wait. And this one is a little trickier. Some people like this trick. For other people, it's just a little too confusing. You can recognize hydroxide as a polyatomic ion. And if you have water on the other side, you can actually separate water into HOH. H2O really is the same thing. We'll try some of those live in class. It's not totally necessary to do it that way, but once again, this is a trick or a hint. If it works for you, if you can remember to do it, you may find that it's a little bit easier. So you guys are now ready to be great at balancing. The trick now is to just keep practicing, keep balancing, keep coming at these problems, and you'll get better and better as you go. I'll see you in class.